Have you ever stopped to think about the invisible forces that are literally running our world? From the simple act of walking down the street to the massive orbit of the Earth around the Sun, it's all governed by a set of rules. Today, we're going to pull back the curtain on two of the big ones: friction and circular motion.
We've all been there, right? You're trying to rearrange the furniture, you're putting all your weight into this heavy box, and it just won't move. What is that? What is that invisible wall fighting you every single step of the way?
And then think about this. What is that invisible force that grabs your car and yanks it around a sharp corner, stopping it from just shooting off in a straight line? Well, the answers to both of these puzzles lie in the physics we're digging into today.
Okay, first things first. Let's talk about that stubborn force, that resistance to everything. We are diving into the secret of friction.
So what is it, really? In the simplest terms, friction is the force that fights back whenever two surfaces try to slide past each other. You can think of it as the ultimate opponent of motion.
Now here's where it gets interesting. Friction isn't just one thing. It actually comes in two main types. First, you've got static friction. That's the really strong stuff, the get-going friction that you have to overcome just to start moving something. But once you get it moving, a different, weaker force takes over. That's called kinetic friction, and that is exactly why it's always way harder to get that heavy box to start sliding than it is to keep it going.
Okay, but where does this force actually come from? I mean, you look at a tabletop or a polished floor, and it seems perfectly smooth, right? Well, if we could zoom in with a super-powered microscope, we would see a totally different world.
And here is the big secret. On a microscopic level, no surface is smooth. They're all covered in these tiny little mountains and valleys, these imperfections. So when you press two surfaces together, those little bumps and grooves actually lock into each other, kind of like the teeth of two gears. And that interlocking, that is what creates the resistance we feel as friction. As you can imagine, having those surfaces grind against each other is super inefficient. It makes dragging things a real pain. But humans came up with one of the most brilliant solutions in history. We didn't get rid of friction, we just changed the game.
And that solution, of course, was the wheel. This introduced something called rolling friction. See, instead of those microscopic teeth grinding and locking, rolling just kind of squishes the surface a tiny bit, which creates way less resistance. The takeaway here is huge. Rolling is just monumentally easier than sliding. And that one idea, that one invention, changed everything about how we build our world.
So we figured out how friction fights against motion in a straight line. But what happens when we're, well, not moving in a straight line? In fact, sometimes friction is the very thing that helps us turn and go in a circle, which brings us to our next topic, the physics of going circular.
All right, here's a little brain teaser for you. A classic physics question. Picture a satellite zipping around the Earth. Its speed is perfectly constant, let's say. So, is it accelerating? You'd think no, right? Constant speed means no acceleration. But actually, it is. How is that possible?
The secret is understanding that speed and velocity are not the same thing. Speed is just a number. It's how fast you're going. But velocity is your speed plus your direction. And since an object moving in a circle is always changing its direction, its velocity is always changing. And any change in velocity, by definition, is an acceleration.
So to make something accelerate, to pull it out of a straight line and into a circle, you need a real physical force to do the pulling. We call that force centripetal force. It literally means center seeking. It's the force that's always yanking the object toward the center of the circle it's tracing. For a planet, that force is gravity. For a ball you're swinging on a string, it's the tension in the string.
Now, this brings us to one of the biggest mix-ups in physics. Centripetal force is the real force pulling you inward. But what about that feeling of being thrown outward when you're on a fast-spinning ride? That's often called centrifugal force. But guess what? It's not a real force at all. It's what we call an apparent or fictitious force. It's really just your body's inertia, your tendency to want to keep going in a straight line, fighting against the inward pull. So remember, centripetal is the real pull in, centrifugal is the fake feeling of being pushed out.
So this stuff isn't just theory, right? We actually use these invisible forces every single day. Engineers are constantly playing with friction and centripetal force to design and build the world around us.
A banked road is just a brilliant piece of engineering. On a totally flat road, the only thing that lets your car turn is the friction between your tires and the asphalt. But by tilting or banking the road, Engineers get the road itself to help out. The tilted surface pushes up and sideways on the car, giving it a nudge toward the center of the turn. This means we don't have to rely entirely on friction, which makes taking those highway curves at high speed a whole lot safer.
Or let's think about a roller coaster. We've all seen a loop-the-loop. As you go up and over the very top of the loop, for a moment, gravity is actually pulling you in the same direction the centripetal force needs to go, down toward the center of the loop. Because gravity is helping out, the track doesn't have to push down on you very hard. And that's why you get that incredible feeling of weightlessness at the top.
But at the bottom of the loop, it is a totally different feeling. Down there, the track has to provide a massive upward force. It has to push hard enough to bend your path upward into the curve, and it has to fight against gravity, which is trying to pull you straight down. That huge upward shove from the track is what pins you to your seat and makes you feel super, super heavy.
All right, pop quiz time. Let's do a quick check to make sure this all clicked. First question for you. Which kind of friction is the one you have to fight before something starts moving?
That's right, it's static friction.
Okay, second one. When you have an object moving in a circle at a perfectly steady speed, what is the one thing that is always changing?
You got it. It's the velocity, because that direction is changing every single instant. And that really brings it all together. From taking a single step to driving around a bend to the orbit of our own planet, friction and centripetal force are like the invisible architects of motion. They're always there, shaping everything. So I'll leave you with a final thought. Just imagine for a second, what would our world even look like if, suddenly, these forces just vanished?